Okay, to test to see if a composite function exists, we need to know the domain and range of each part of the composites. So if I've got k of x equaling x squared minus 4, now that's going to be a parabola that is down here looking like this. Therefore, it's going to have a domain of k, which is all real numbers, and a range of k, which is -4 to infinity, inclusive of -4. And if this is my parabola that's been, my square root that's been moved 1 unit to the right, then the domain of p is going to be 1 to infinity, inclusive of 1, and the range of p is going to be 0 to infinity, inclusive of 0. So, does k of p of x exist, why or why not? So, if k of p of x exists, then the range of the inside, which is p, that's the inside, has to be a subset of the domain of the outside, which is k. The range of p is 0 to infinity. The domain of k is all real numbers. Yes, it does fit in. Yes, therefore, k of p exists. Give you reasons why or why not, including this line here, which uses your range of p and domain of k and places it there with the correct symbol. That is your reasoning. You don't have to write a sentence. This is your ending up statement. So to check and see with p of k of x exists, so if hoc of x exists, then we would expect the range of k to be a subset of the domain of p. The range of the inside sits inside of the domain of the outside, and the range of k is -4 to infinity, inclusive of -4, and that's 1 to infinity, and that is not a subset. So I put a line through the subset symbol. Therefore, hoc of x does not exist. So that's how you test to see whether a composite function exists or not.